Greetings, Calc 2 students. This video is for section 5.3, question number 75, and it specifically relates to the WebAssign homework from the Fundamental Theorem of Calculus, question number 10 that we find in WebAssign. So the instructions that were given are to evaluate the limit by first recognizing that the sum as a Riemann sum for the defined function on 0 to 1 interval, including 0 and 1. And then we're told that the question then is the limit as n approaches infinity, the summation from I equals 1 to n of I to the fifth divided by n to the sixth plus over n squared. So the key to this problem is remembering that the definition that we want to use here is the integral from a to b of f of x over dx is equal to the limit as n approaches infinity of the summation of I equals 1 to n of f of xi times delta x. That's the definition that we were working on in the previous section, where delta x equals b minus a over n and xi equals a plus I times delta x. So let's write down a couple of things here. The interval from 0 to 1 means that a equals 0 and b equals 1. That's what that means. And so delta x is equal to 1 minus 0 over n. And so that simplifies to 1 over n. That's my delta x. And then my xi is equal to a, which is 0, plus I times delta x, so that's 1 over n. And that all simplifies to just I over n. Okay, so let me recopy the problem here. So this is the limit as n approaches infinity, the summation I equals 1 to n, and then I to the fifth divided by I to the sixth plus 1 over n squared plus I over n squared. So the first thing I want to point out here is what I have listed here is not exactly like the definition that we find up here, but it's close. It doesn't have a delta x. But what is my delta x? Well, my delta x is 1 over n. That was what my delta x equals to. So I can get a delta x here by factoring out a 1 over n, and I haven't changed anything algebraically. So this is equal to the limit as n approaches infinity, the summation I equals 1 to n of, and I'm going to factor out a 1 over n out of each term. So I have I over n to the fifth plus I over n, and that can be multiplied by 1 over n. So what I did was take I to the fifth and left it alone. I factored out a 1 over n out of this term and put that out here, and that left me with one of my n's is gone now, it's over here. So that left me with I to the fifth over n to the fifth, and I just combined those together. Then I took out 1 over n out of this term and wrote it on the outside, and that left me with I over n. Okay, so now I've accomplished the first thing that I wanted to accomplish. So I have the limit as n approaches to infinity, summation I equals 1 to n, and this is I over n raised to the fifth plus I over n, and then this is times delta x, because remember this term 1 over n is the same as delta x. And then my xi is equal to 1 over n. So this is xi. This is xi is I over n. Sorry, I said 1 over n, but xi is I over n. So let's substitute that then. The limit as n approaches infinity, summation I equals 1 to n of xi to the 5th, because this is I over n, which is the same as xi to the 5th, and then plus xi times delta x. And this xi and this xi, I over n, I over n, I over n is the same as xi. So now, from the formula that we started with, I have this form on the right-hand side, and then I can rewrite that as this definite integral on the left. So let me copy that down. This then is equal to the integral from 0 to 1 of x to the 5th plus x times dx. So I took this and transformed it to that. Okay, now I just use the fundamental theorem of calculus to finish this problem. So this would be x to the 6 divided by 6 plus x squared divided by 2, evaluated from 0 to 1. And then that would be 1 over 6. So this would be 1 raised to the 6 is 1 over 6. And then plus a half. And then minus 0 minus 0. Put in the 0 for x, it would be 0. Put in the 0 for x, it would be 0. So that is 1/6 plus 1/2, which is the same thing as 1/6 plus 3/6, which is 4/6, or the same as 2/3. Now remember, your problem might be slightly different because of WebAssign changing the values of some of the exponents. Okay, hope this helps, and if you have any questions, please let me know.